This is problem number 4 from section 9.5. It says find, if possible, A times B and B times A. Now, these two matrices have dimensions of 2 by 2 for this one, and this one is also 2 by 2. To do matrix multiplication, we're going to multiply each row by each column. But in order to multiply each row by each column, there's a really important piece of information that we need to make sure that we have. And that's to multiply an m by n matrix, so in our case 2 by 2 matrix, by an n by p matrix, just meaning they're two different matrices. So this would be our other 2 by 2. The ends must be the same. So the ends, if you notice, are the middle, where you got the ending columns, so the columns and the rows. So the columns of the first matrix has to match the rows of the second matrix. As you notice, the columns of our first matrix does match the rows of our second matrix. And so if those two things match, the columns by and the rows, then we can actually do the multiplication. And you'll see down here that the ends are the same and the result is an m by p matrix. So if I take the first matrix, m by n, and I multiply by the second matrix, which is n by p, the ends have to be the same, so that's the middles, right? That'd be the middle two numbers. And the outside two numbers, right, the m and the p, actually tell you the dimensions of your new matrix. So when we multiply a 2 by 2 by a 2 by 2, it's no wonder that it's a 2 by 2 for a result. But when you do this with other matrices like 3 by 2s and 2 by 3s, sometimes you'll get maybe a matrix size that you weren't expecting. So in this case, we're doing a 2 by 2 by a 2 by 2, so we'll end up with a 2 by 2 as a result. So I'm going to go ahead and write this out. And I like to write these out and make just a really large matrix so we can put all the multiplications in there. So we're going to make a pretty large 2 by 2 matrix. And then when we actually do the simplifying, we'll make it smaller. So I've got to take row 1 times column 1. And this is really important. We're going to label these. This is row 1, and this is row 2. This is column 1, column 2. Because when we multiply, we're multiplying each row by each column. So we're going to take row 1 times column 1, and that's going to be the 1, 1 spot, right? The upper left-hand corner of our 2 by 2 matrix. So I'm going to take 8 times the 5, right? So we're going to do the first term of the row times the first term of the column, and then the second term of the row by the second term of the column. So 8 times 5 plus 1 times 9. And then I'm going to take this row times this column. So 8 times 2 plus 1 times negative 4. And then I'm going to do the same thing down here for the second row. Negative 8 times the first column, which is 5. So negative 8 times 5. And I'm going to add it with negative 2 times 9. And then I'm going to take negative 8 times so I'm going to do this row 2 times column 2, so negative 8 times 2. And I'm going to add it with negative 2 times negative 4. And when you do that, you end up with 8 times 5 is 40 plus 9, so you end up with 49. And you can put that in the calculator to figure all this out. 8 times 2 is 16 plus 1 times negative 4. So we end up with 16 minus 4, which is 12. This is negative 40 plus negative 18. So that's negative 58. And negative 16, this is actually going to give you a positive 8. So negative 16 plus 8 is negative 8. And that's for part A. Now part B, we're going to do the same thing. We're going to do it backwards now. So instead of this, we're starting with this row and these two rows. We're actually going to start with these two rows, and these are going to be the column parts. So I'm going to go ahead and mark those with a different color. I think that'll be the best way to keep all this separate. So actually I'm going to mark this part B, and this is going to be for the second part. That's row 1, row 2, and this is column 1, column 2. Okay, so we can ignore the pink for now. Let's make our 2x2 matrix. We're going to start with row 1. We're going to take 5 times 8. So 5 times 8 plus, and then 2 times negative 8. Then we're going to come back to row 1 and do it times column 2. So 5 times 1 plus 2 times negative 2. And then we're going to go to row 2. Row 2 is 9 times 8 plus negative 4 times negative 8. And then we're going to go to 9 times 1 plus negative 4 times negative 2. You can see we did this row times this column, then this column, this row times this column, then this column. We're going to add those up. This will give you 40 minus 16, so it's 24. This is 5 and negative 4, so that's 1. This is 72, and then 32 more. So 72 and 32, 104. And then 9 and that'd be 8, so 17. And that's the solution for our second multiplication, b times a.